first page right here. So what I want to do really quickly is just run through what's in the packet, what we're going to do. One of the reasons that we're doing this multiplication and division review is because I noticed when we were doing the state test practice, the interim tests, that some of you guys have forgotten some things. I also think that I don't have an issue with you guys continuing to use your multiplication charts when we do things like this. We can also work with our tables to help one another, not give each other answers. That doesn't help, okay? Helping is completely different. But I do want to say the goal with the multiplication tables is to begin to memorize your facts, okay? We're trying to memorize our multiplication facts. So that way when you guys get to taking tests, like you're going to be taking starting tomorrow, that way you guys will remember them, okay? But there are some tricks. Now, everybody, look up here. The first page in this packet, we haven't done this for a while. It's been months since we did this, okay? But here's what I want. This is the most important thing right now. When you guys sit down, you take that test tomorrow, and when you do any other type of, focus, you do any other type of math in the future, I want you to remember the different techniques that you can use for multiplication and division, okay? So for multiplication, the first one that we're going to start our review on is repeated addition. Does anybody remember what repeated addition is? Anybody remember what it is? Zoe? So yes, that's right. Repeated addition is related to multiplication because you can use repeated addition to answer multiplication equations, right? To find the products. You can use it. That's what the goal is here. So on this page, guys, I need everybody paying attention here because when I walk around the room in a little bit, Jed, you included, I need you guys to have shown me that you were using repeated addition. It's not just finding the right answers. I want you to use this particular method because when you get into the higher numbers, you can do the same thing. It will help. Odd sound register. So, let's look at this one together. How can I do this using repeated addition? What can I do? Andrew? That's right. 7 plus 7 plus 7. Now, another thing that I've noticed you guys doing when you do addition lately is some of you guys are trying to do it this way in sort of a linear, horizontal way instead of lining them up, and you're trying to add all three numbers at the same time, or all 3, 4, whatever it is. I think we had something with 4 numbers last week. I really, really recommend that you guys break it apart a little bit, okay? Do it like this. 7 plus 7 is what I'm trying to write. That is not an eraser. Do 7 plus 7 first. What's 7 plus 7?
14.
It's 14. And then what's 14 plus 7?
21.
That's right. So 7 plus 7 plus 7 equals 21, which means that 3 times 7 equals 21. Okay, so you see what we're doing on this one? We're just remembering the different methods, the different techniques, tricks to remember or to do these multiplication problems. So if you come across one that you don't remember, maybe 8 times 3, maybe something bigger, break it apart. This is one way that you can do it, okay? Now I know, again, some of you already memorized these, that's okay, but I want to know that you know how to use the methods, because you may be asked to do this in the future. Now, on the next page, everybody take a look at the next page. We've got repeated addition number sentences. This time, it's already broken apart. So not only do I want you guys to give me the sum for the addition problem, I want you to write out the multiplication equation, okay? So on this one, how many 7s do we have there? Jack?
5.
We have 5 7s. So what is the multiplication equation here? Allie?
5 times 7.
That's correct. And what is the product of 5 times 7? Andrew? What is it? I couldn't hear you. I'm sorry. 35. That is correct. Now, of course, with the fives, guys, everybody in here knows how to skip count with their fives, right? Yeah? 5, 10, 15, 20, 25, 30, 35. And that's the same. You're doing the same thing, right? Okay, so just remember that on this one. Now, of course, there's some limits to, let's call them drawbacks to using repeated addition, right? Because when you get to some bigger numbers, that's what you've got, a lot of nines to add. Which is why, and I think you guys will learn by doing this, a lot of twos to add right here. I think you guys will learn by doing this that multiplication is actually easier when it comes to having a lot of numbers you need to add together. Okay? Everybody take a look at the next page. Skip counting. Skip counting, you guys know this one. But look at what the instructions say. It says show how to skip count by 2, 3, 4, and 5 on the hundreds charts below. So here's what you're going to do. You are going to, I'll start out this first one here on the skip count by 2s. What I want you guys to do is circle each number when you're skip counting, okay? So this one would be 2, 4, 6, 8, 10, and so on, all the way down. But you're going to do it differently for each one. Next one, skip count by 3s, then 4s, then 5s. Allie.
Remember when we were on musicians and we did like a skip count?
We did.
That Christmas special?
We did.
My dad taught me there was a pattern.
Yes, there are patterns, absolutely.
So, like, 2, 4, 6, 8, 10, it will repeat.
This is true. That is true. And on this one, look at this one right here, though, too. There's another pattern. There's another easy way to look at this one, isn't there? Because your next one's going to be 12, 14, 16, 18, and 20, which tells you that those columns all the way down will be your 2s on this one, right? Which is right. There are absolutely patterns. Any pattern that you find that helps you remember these, use that. Go back and look at the information you already know. Now, next one. Everybody flip to the next page. I know you're all eager to get started, but we're going to go through it really quickly first, and then we'll get started, okay? Multiplication table. We've done these. I want you guys to fill this in. Try to fill it in without using your multiplication charts on your name tags. Okay, try it. Give it a try. Remember how it works. Remember how these ones work, guys. The outside numbers are your factors. Right? These are factors. The inside numbers are your products. So the outside numbers are the numbers that you're multiplying together, right? So what's 1 times 1?
1.
What's 1 times 3?
3.
There you go. Plus that first line is going to be the easiest because it's just going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because they're all ones, right? What is the identity property again? Who wants to tell me what the identity property is, Allie?
I know what it is, but I don't know what to say.
You know what it is, we don't know what to say. Ariana? That's right. Did you guys hear what she said?
Yeah.
That's right. And I know you were going to say something similar. I know you know this one.
Yeah.
So any factor multiplied by 1, the product is that factor. That's why 1s are so easy, right? Jen?
There's an error in the
Where's the error?
on the 9 and there's 2 9.
2 9s. Let's see, where are we? On which one? On number 9 down below? Let's take a look. Yeah, look where he's right. That 9 should actually be right here. Not here. He's right. There's an error. Thank you for pointing that out. So in that spot, that should actually be blank. So you're going to put a different number there. But the 9 should be on that side. Because remember, right here are still ones too. This should just be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on the outside. Nick. On the 10, what's on the 10? You think the 30 is not on the third? Oops, I went too far. Looks like it's on the third to me. Are you talking about right here?
Yeah.
Yeah, that's on the third. 10 times 3. That's the right spot. Going which way? What do you mean? Oh, you're talking about the one on top? I don't see an error on 10. I don't see an error for either one of the 10s or the 3s. Is anyone else saying what Nick's talking about? Here, Nick, show me on yours. Ready? Make sense? Who's got it? We're good. We're good. Just remember, guys, this column is still 10 times 1. It's anything times 1 in this column. The very top row and the first column are the ones. That's your identity factor. Okay, so then the next page. Everybody take a look at this one. It says draw a grouping model. And you're representing each division fact with a grouping model. Who remembers what grouping models are? Jack? We'll put them in little groups. Is this what we're talking about? Does it look something like these right here? Yep. You're doing this. What's on the next page? You're making your own on this page. So, what can I do for 28 divided by 7? How can I make that into a grouping model? Schmidt?
Okay. You put 7 rows and then 20 dots.
So that's an array. You're correct. She's talking about an array. If I had, you could make an array to make this work, but it would have to be 7 times whatever would be there, right? But we're going to do grouping models. So we're going to take that 28. We're going to break it down into groups. Who knows how to do that? Again, if you look at the next page, you'll see that. Like this. So what can I do to make this one work? 28 divided by 7. First of all, what is 28 divided by 7? Ariana?
4.
28 divided by 7 is what? Say it again.
4.
Did you say 4? Is she right? 28 divided by 7 is 4. So, what can we do? How can we make this work? Andrew. Could be like that. But what if you didn't know that 28 divided by 7 was 4, and you were having trouble figuring out what else could you do? That's right. So that's the other trick. So let's say we didn't know that it was 4. Look at all those little dots after right. Let's say we didn't know it was 4, but we knew that we had 7, and we're trying to divide 28 by 7. Remember, you're dividing the larger factor, the larger number by the smaller one, right? So what if we went like this? So what if we said we wanted 1, 2, 3, 4, 5, 6, 7. We made 7 groups, because that's really what we're looking at, right? 7 groups. And we said 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, it's 1 away at 14. Okay. 15, 16, 17, 18, 19, 20, 1, 2, 2, 3, 3, 4, 5, 6, 7, 28. It works too, doesn't it? 7 groups of 4. And you counted it out, which meant that you ended up with, oh, wait a minute. I just hit 28. That means that, how many dots are there in each of them? 4. There's my answer. Right? Make sense? Jack. It looks like what? Say it a little louder. Pizza. See, you guys are thinking right. Pizza.
And it looks more like buttons.
I kind of think they look like buttons too, like just really badly made buttons. Or like cookies with not enough chocolate chips in them.
Oh, Cookie Crisp.
Oh, they look like Cookie Crisp.
They
That's
do.
true. Okay, so the next page then, guys, all you're doing on this page is writing the division fact. It says what division fact represents each grouping model. So look at the first one. If you haven't noticed, we're doing each one of those first ones together. Somebody look at that first one and tell me what the multiplication equation is there. What is it? Brewer?
1.5.
That's right. Or, because, what's the property called that says that I can switch those, Ariana? Commutative property. The commutative property says I can switch these around and it doesn't matter. I'm going to get the same answer. What is the answer? What's our product for each one of those? What is it, guys?
5.
That's right. Easy enough. That shouldn't take you guys a lot of time, right? Schmidt, what are you doing? This isn't beauty school. Okay, next one. Now we're moving into our repeated subtraction. Remember how we did repeated addition? Repeated subtraction helps us do division. So if you didn't know the answers to these problems, you could use repeated subtraction. Does anybody remember how to do that? Anybody remember how to do it? Hallie?
The 21 and
And then do what? It'll be 21 minus 7. What if we did that? What does that do? Does that work? That doesn't seem right. What did I do wrong? I made a 0 here, didn't I? Now what do I do? So that was step 1. What if I do 14 times 7? What does that become? 7. Okay. So that was step 2. And then what if I did 7 minus 7? What is that?
You would get 0.
I'd get 0. And that would be step 3, right? So it took 3 steps, 3 different subtraction problems to get to 0. So then what's our answer here, Ian?
This looks like you put ounces or water in there.
It does look like that. This is because when I put a 0 there, I meant to write a 1. But what's our answer then? It took me 3 steps to get to 0. What does that tell you our answer is? Jack? 3. That's right. And I know some of you guys already knew that it was 3 because you know your multiplication fact. But sometimes with division also helps to use repeated subtraction. So I do want to see you guys practice it because you may need it in the future, especially when you get to harder ones. Okay? But you're going to do the same thing with all these. The goal is, how many times do you have to do subtraction to get to 0? That should give you your answer. Yes? That's right. We did it 3 times for that one. We did. Now, here we go again. Same thing. Next page. Now they're actually showing us what it looks like. So 35 minus 7 minus 7 minus 7 minus 7 minus 7 is what? Now I don't just want the answer. I don't just want the answer to the subtraction problem. I want to know what the division fact is. What's our division problem? What are we looking for here? What is 35 minus 7 minus 7 minus 7 minus 7 minus 7? Nick? There are definitely 5 sevens there. Is it 5? But that's the answer, right? But so what's the division problem though? Jack?
35.
Not mine is looking for a division problem. We already have the subtraction. Nick was on to something.
35.
Not 35 divided by 35. 35 divided by Nick. What was the number you counted? How many sevens?
5.
Which equals what? Allie? 7. Now you can always test it out. Make sure that you're right. Test it out. 35 minus 7. 15. What is 15 minus 7? What's 15 minus 7? Jack? Oops. It's supposed to be an 8 right there. And we're going to drop down that. Do it again. That's supposed to be a 2. Now we've got 28 minus 7. What's 28 minus 7? Jack?
21.
And what's 21 minus 7? Nick? 14. Jed, what's 14 minus 7?
7.
And what's 7 minus 7, everybody?
0.
Now we had 1, 2, 3, 4, 5. 5 steps. It worked. It worked. So on these, all you really have to do is count the number of 4s you have, right? And then you figure out what your division problem is. The division fact. 1, 2, 3, 4, 5. So 20 divided by.
5.
Say it.
5.
And the answer's already there. What's the answer? 20 divided by 5 is?
4.
Right. We're giving you hints, guys. The answer is one of those numbers. Okay, so now on the last 2 pages, stop before you get to these because these are going to do with a partner. One of these is roll and color multiplying 2 numbers together. And the next one is going to be also multiplying 2 numbers together with bigger numbers. So the products are there. Your dice will give you the numbers. But you're going to stop before you get there, okay? So the goal is we're going to try to get through these pages. It seems like a lot, but I don't think it's going to take you guys that long because it's review. And then what we will do, before we move on to the partner part, is we will go through all these together and make sure that we all have the same answers. Okay? Any questions before we start? Everybody should be on this page right here. Repeated addition. Repeated addition. Let's see how far we can get here. Go ahead and throw that away. Everybody on this page, thumbs up. Everybody better be on this page right here. Ian, flip back to this page. On the repeated addition page. So everybody has the first one because we did the first one, right? Now, I showed you guys how I would actually add them up to double check the answers, right? Now, you don't have to do it that way necessarily, but I think it's a lot easier to line up your addition problems like that. Brewer, question? Yes. Okay, 4 times 5. What are we going to do for 4 times 5, Joel? To make it into a repeated addition problem. 4 5s. 5 plus 5 plus 5 plus 5. Now the easiest way to, we could have also done 5 4s too, right? But this one's easy because skip counting by 5 is easy, right? So guys, everybody should know this one. What is 4 times 5?
20.
That's right. 5, 10, 15, 20. That's it. That's all you have to do on this one. Next one. Let's look at this one here. 8 times 3. Nick. On 8 times 3, you should be on this page. What are we doing over here? On 8 times 3, how can I use repeated addition there? That's right. 8 plus 8 plus 8. Now, if you're really good and you guys remember how to do it, you can skip count. You could skip count by 8s, right? Or you can add them up to get your answer, right? 8 plus 8 is 16. Then after 16, you would add another 8 to it. So what's our answer, Ian?
24.
That's right. Now what about 6 times 4, Zoe? Nick, what are we doing on the ground here? 6 plus 6 plus 6 plus 6. That's it. And it also equals 24, which is right. The other way you could have done that also, if you needed to very quickly add it up and you didn't know that, 6 plus 6 is 12. 6 plus 6 is 12. 12 plus 12 is 24. See what I mean? Okay, next one, guys. 4 times 4. How can we do that, Andrew, as repeated addition? And what's the answer, guys? Everybody?
16.
Ooh, I heard somebody say 18.
16.
I'm hoping you said 16. It's 16. And another way to do that. Break it apart. 4 plus 4 is 8. 8 plus 8 is 16. See what I mean? Ignore my weird squigglies. Allie, how can I do 8 times 2? Go ahead and throw your trash away, but how can I do 8 times 2 as repeated addition? 8 plus 8. It also equals 16. That's correct. We had 2 in a row that equals 16. Now, what about 4 times 9 Schmidt? What can I do?
Okay. 4 nines and it equals 36.
9 plus 9 plus 9 plus 9. That's just right. It equals, I don't know why I wrote equal again, 36. Another way you could do that again. 18 plus 18, 36, right? Okay, 7 times 4, Ian. How can I do that as repeated addition?
4 plus 4 plus 4 plus 4 plus 4, just plus 4 7 times.
You can do plus 4 7 times. He's right. How else can I do it? What's the other way, Ian? Instead of 4 7 times, could I do 7 4 times?
Yes.
Yes, I can. 7 plus 7 plus 7 plus 7. Now, the reason I chose to do it that way, he's right, you can do it the other way, but the reason I chose this way is because I had to write fewer numbers. I didn't have to write as much, right? 14. What's 14 plus 14?
28.
28, which means that 7 times 4 is how much?
28.
That's right. Any questions on this page? Any questions on this page? Heston?
I have 2 questions.
2 questions on this page.
Why do you write your sevens like that? Second question.
I just do.
Second question. I have like 4 more problems.
Good.
on the last page.
I'm glad to hear that.
Can I finish that? Because it's
Right now, we're going to go over this, and then we'll talk about that. Okay? We're going over this together first. Jack, question.
we were doing this one, I was on the wrong page.
Ah, then you realized it. Good. Well, let's move on to the next page. Let's take a look at this one. Remember, this one is the same thing. It's just reversed. Instead of giving you your multiplication fact first, they gave you the addition. And then your job is to find out what the multiplication fact is, and I want the product. Okay? So, how many 4s do I have here? 1, 2, 3, 4. What is, Wilkins, the multiplication fact here? What's the problem? What's the multiplication equation?
5 times 4 equals 2.
Did I say there were 4 4s? There are 5 4s. He's correct. 5 times 4 equals 20. Now you could have done that by adding it up, right? 8. 4 plus 4 is 8. 4 plus 4 is 8. 8 plus 8 is 16. 16 plus 4 is 20. And you could have added it up just like that. Or you could have just looked at it and said, wait a minute. 5 times 4, 5, 10, 15, 20. Skip counting by 5 is easier, right? Next question. Go ahead. Joel, go ahead as well. Okay. Now, what about moving on to our next table back here? Heston, 7 plus 7, how can I write that as a multiplication fact, as a multiplication problem? How many 7s are there? So it's 7 times what? What's it equal? 14. That's right. That's right. That's probably one of the easy ones, right? Alec, question. That's okay. It's just water. Don't worry about it. Okay, Aiden, what's our multiplication fact here? How many 2's do we have?
9.
So what's the problem?
2 times 9 equals 18.
That's correct. That is correct. Now you could have skip counted there too, right? 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, next one. Oops. 5 plus 5 plus 5. Brewer, what is the multiplication fact? 3 times 5. She's right. And it does equal 15 again. 5, 10, 15. Now we could have done 5 times 3 as well, right? Commutative property, same thing. Okay, what about this one here, Jack? 6 plus 6 plus 6 plus 6.
9.
Are there 5? Are you sure?
24 times 6.
That's right. And what's our answer?
24.
That's right. Good. And the more you're going to see these, the more you'll remember them, because we already had that problem, right? Now remember, 6 plus 6 is 12. 6 plus 6 is 12. 12 plus 12 is 24. Okay, so next one here. 8 plus 8 plus 8 plus 8. Talent. How can I write this one as a multiplication problem? As a multiplication fact.
8 times 4.
That's right. 8 times 4. And what is the answer to that? What's our product there? 8 times 4. 32. He's exactly right. Good. 32. 8 plus 8 is 16. 16 plus 16 is 32. Okay, what about this last one here, Ariana?
6 times 9.
And what's the answer?
54.
54. That's right. Good. You guys got this. Anybody have any questions on this page? Everybody feel pretty good about this page? Thumbs up? Good. I'm glad to hear that. This is just a way to help you if you ever get stuck. Remember that multiplication can be solved. Multiplication equations can be solved using repeated addition. Yes, Nick? Yes, go ahead. Okay, next page. Skip counting. Well, we started this one already, right? And we would keep going because we learned on this one that the pattern gives us columns all the way down. Once you see the pattern, it will help you complete it. Now, of course, I want you guys to go through and actually know these answers too. But once you see the pattern, it helps you do the whole thing. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 20, 24, 26, 28, 30, 32, 34, and so on, all the way up to 100. Skip count all the way up to 100. Tom, question? You want to do the skip count by 5? Well, we'll see, because I'm trying to make my way all around. But I think we can come back to another. Jen is going to help us with the 3s, though. What should our pattern look like here, Jen, on the skip counting by 3s? We're starting with a 3, right?
3, 6, 9, 12. 15, 18, 21, 24, 27, 30,
Good.
36, 36, 38.
Now, do you see this pattern? Do you guys see the pattern emerging? There are 2 between each of them. Did you see the pattern, Jed? Do you see what happens here? Right? Diagonal lines. All the way down. See what I mean? And then from 57, we would go to 60. And from 87, we go to 90. Is that what everybody has right there? Yes, Jed.
But how would you add 3 to 99?
If we add 3 to 99, we're going to end up over 100. So that's where we stop. We stop at 99. We could keep going, of course. You could keep going forever, literally. Forever. But we won't, because that would take years for us to just keep going. We could go to a billion. We could go to a trillion. We could go even further than that. Yes, Allie, question. I'm sorry to hear that. Stop touching it, though, okay? You might have something in it. Do you need to go check in the bathroom? You sure? Stop touching it. Don't touch it. Nick, question.
You know how long it takes to count the numbers?
Well, it depends on the person. There you go. Okay, skip counting by 4s. Let's see. I know Talon wants 5s. So I'll go to you for 5s, but who's going to do my 4s for me? Allie? Okay, tell me my 4s.
4, 8, 12, 16, 20.
What's next?
24,
That's right. What's next after that?
28,
Yep.
32, 36,
That's right.
40, 44, 48.
These aren't so bad, are they, after you look at it for a while? Yes, anyway. So then after that, what happens?
Oh, wait, which number was I on?
There's another pattern.
Wait, I was on 48, right?
Yes, you were. You were on 48.
52, 56, 60, 64, 68,
That's right.
72, 76, 80, 84, 88,
Mm-hmm.
92, 96, and 100.
Do you guys see that pattern? You guys see that pattern there? They're like little, if you look at it, first of all, of course, you're skipping 4 each time. I think it's kind of the 4s. But if you notice, when you're going down your columns, you're skipping 1 each time. Right? Each time. Across, there are 3 in between. But if you look at them, they're also like this. You see what I mean? Once you start establishing the pattern, then you could fill the rest of it in without skip counting all the way because you see the pattern. Just make sure you double check your word. Now, talent. 5s. What do I do?
5, 10, 13, 14, 15, 16, 17, 75, 80, 85, 95.
Easy pattern, right? Good. Good. We just had 2 columns. That's it. Go ahead, Heston. Question, Ian. Did you have a question? Okay. Jack, go ahead. Good, guys. Nick, do you have a question? Can you go up to what? Oh, you needed to see 2 and 3. You want to double check your work? So with the 3s, so you notice with the 2s, they're very similar to the 5s. 2s and 5s are some of the easiest numbers to skip count, right? And the columns just go straight down. See? Straight down. Now with the 3s, they're diagonal. You guys see that? They're patterns. That's how math works. It's all about patterns and relationships, right? We talked about that before. Good. Does anybody have any questions on the skip counting page? Anybody stuck on anything on the skip counting page? Any questions? Schmidt. Can't tell us? You might help somebody else. What are you stuck on?
Okay. I'm not seeing. Okay, I got some of these.
Spelled wrong. Silent W. Everybody's nowhere.
So just.
Okay. Good. Thank you for showing. It's okay to make mistakes, guys. That's how we learn. Now, guys, we talked about this. Outside of the factors, those are the things that you're multiplying, the numbers you're multiplying. Everybody go to that multiplication table. Let's take a quick look at that. Quick look at the multiplication table, and then we will take a break on this for now. Okay, 1, 2, 3. This should be 4, 5, 6, 7, 8, 9, 10, 11, 12. Easy. My recommendation, as soon as Heston's back and go. My recommendation is do the easy ones first, okay? So then go to the column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now you've got those established. The next easiest one would be the 2s. And you do the same thing. 2s across in the row and 2s down in the column. Jack.
Can I do the 3s?
You can. Let's do the 2s first. Who's doing my 2s for me? Brewer. 2.
2, 4, 6, 8, 10, 12, 14, 16, 18,
What's next?
20, 22, 24.
That's right. And we would do the same thing on the column. 2, 4, 6, 8, 10, 12, 14, 16. We know that that 9 was in the wrong spot. One of you guys very rightly pointed that out. That should be 18, 20, 22, and 24. Okay, now we've got our 2s done. This is the easiest way to fill these out, guys. And if you're not done, you should be looking at it. Now the 3s, Jack.
36, 9, 12, 15, 18, 21, 24, 27, 30, 33, 32.
There you go. Same thing all the way down, too, right? Same thing all the way down.
I have a question.
And what's your question?
I only use my number 12 on 12 and 9.
Okay. Good. Good. Other question.
Two questions.
Go ahead, Amy.
Can I do the fourth one? And the other question, you wrote 20.
Where? That's a 4. It's just a badly drawn 4. Here, I'll make it worse.
No!
Better or worse?
It's worse.
It's worse. 24. That's a 24. I just drew it too quickly. I see a lot of questions. Are these all questions about this? Jen.
Can I do the 9?
Jen wants to do the 9s. Who asked me to do the 4s? Ali asked me to do the 4s. Okay, hold on. Let's do them really quickly then. 4s first, because 4s come before 9s. Okay, we'll do the 4 row first, and then we'll do the column. We shouldn't even have to do the top of the 4s, right? Because we already filled those parts in. So where do we start here? We've got 4, 8, 12. What's next? That's 8.
You're making it hurt.
Okay, what's next? After 12.
16.
What's after that?
20.
What's next? 24. What's after that?
28.
What's next?
32. 36. 40. 44.
I shouldn't hear anybody else talking. Good. And then we would do the same thing going down. And each time we have fewer to do, right? Because we're filling in more and more as we go. Right? 40. Now, if it helps you, you could also, and this is what I recommended to a lot of you guys, was to also go and do really quickly your 10. Now, if we had already done the 10s, we would have some other things filled in. 10, 20, 30, 40. Guys, count with me.
50, 60, 70, 80, 90, 100, 110, 120, 130.
Okay. So now those are done. Now we want to do the same thing across here too. What's next? What's next?
50, 60, 70, 80, 90, 100, 110, 120.
Perfect. So now those are already filled in. So then, the other option also would be to see what else would be easy for us. Well, if you're at a place where you don't think any more of these are easy, then you would want to just kind of keep going down. Now we have another 5. We have 5s to do. 5s are easy. 5s is another area where you might want to do 5s. I think we could do 5s together, correct? I think we do the 5s together. Plus we have several of them filled in. We actually have 5s filled in all the way up to 20. What comes after 20?
25, 30, 35, 40, 45, 50, 55, 60.
Good. And we do the same thing this way. Oops, that's supposed to be a 4. Allie's going to judge that 4. 45.
It's messed up.
It's a messy 4. 45, 50, 55, and 60. Okay, now look how much of this table's filled out already. Look how much we don't have left. We barely have anything else to do. Okay, who's doing 6s for me? Who's doing 6s for me? Aiden? You want to do 11s? 11s are pretty easy. Let's do 11s. Let's do 11s. We're up to 66 already with 11. What's next? Aiden, what's next? Hey, Wilkins.
77, 88, 99, 110, 121, 132.
Yeah, perfect. Now, of course, we would do the same thing over here, right? 66, 77, 88, 99. And you want to know why 11s are really easy too? What's it called? What's the property called? What makes it easy? Property?
Double.
Doubles is good, but that's not what it is. It's called it applies to the number 1. And it's why this one is easy. What's the property where when you multiply 1 by any factor, the answer is still that factor?
Commutative.
No, that's when you reverse things. What's it called? Ariana? Identity property. That's what makes this one easy because you're working with 2 1s. So the 2 1s by anything will still be that factor, right? That's why you have 100 and it looks weird here, right? It starts looking a little weirder when you get up here. But it makes sense. Because it's also 10 plus 1. Aiden, what was your other question?
I cover something getting really irritating.
Okay, let me give you a Band-Aid. Okay, Wilkins, you have a question?
Yes. Can I do 12?
Yes. Aiden, come on over here. And as soon as actually I'm getting really fast. Okay, both are out. Yeah. Good idea to cover it up too. This one right here. There you go. Okay. Wilkins, you wanted to do 12s? Well, let's look at 12s. And do either of these two confuse you guys? Because I know up to 10 it kind of makes sense, right? 88, 99, they're just they're doubles of the number because you're multiplying by 2 1s, right? 11. Does this make sense? Does this make sense?
Oh,
Are those confusing to you guys?
really?
A couple of you guys? Some of you guys? Because if you looked at it and you said 11 times 11, you got 1 times 1 is 1. 1 times 1 is 1. But remember, now you've got a second row of 1s, right? So you add a 0. 1 times 1 is 1. 1 times 1 is 1. 1, 2, 1. See what I mean? That kind of makes sense. Once you get up there, things change a little bit. They look a little bit different. And then you kind of have to look at it like multiplying by 10 plus 1. So, for instance, multiplying 10 times, or look at it this way too, of course, this works. Because you're looking at 11. 110 plus 11 is 1 plus 11 is 132, right? So that means that the next one would be, does anybody know what would come after 132? 11 times 13? Jack?
143.
That's right. You got it. Look at that pattern, guys. Look. 1, 2, 3, 4. 1, 2, 3, 4. It's just going to start counting up. You'll see the patterns. They're everywhere. Schmidt.
Can I do 6?
Okay, hold on. We've got Wilkins is doing our 12s. We're at 60 already. So what's after 60?
72.
What's after that?
84. 96.
What's next?
98.
98?
Oh.
You know this one because you showed it to me. You already had it. You showed this one to me. He knows what it is. 96 plus 12. We talked about this one. 96 plus 12.
112.
Yeah, who knows it? Jack?
108.
108. Right? Because then also 108 plus 12 is 120. And then you've got 132. What comes after 132?
120.
Can't go back down. It has to go up. It has to go up. What is 132 plus 12? 132 plus 12, Nick? So 144. He's got it. Good job. They should always be going up. He's looking at 132 plus 12. 2 plus 2, if you want to do this mentally. 2 plus 2 is 4. 3 plus 1 is 4. And then, of course, you drop the 1 down. Yes?
I was doing it other way. I wasn't going down.
Aside to the sides should still be the same, right?
I know, but when you said
Oh, you were on a different.
I was on a different one.
Oh, I see. So this is 72. Then we've got 84. What comes after 84?
96.
And then what comes after 96?
108.
That's right. And then 120 and 132.
And then when I said 120, you said it was.
Well, that's because we were on this one. So we were doing the columns first and rows next. Go ahead. Okay, good job. You've got it. As long as you have those, you've got it. Now, who asked me to do 6s? Schmidt. 6s. We're on 30 right here. What's next?
Okay. 36, 42, 48, 54, 60, 66, 72.
Yep. Then we would do the same thing down, right? 36, 42, 48, 54. And it's getting easier and easier. We only have 2, 4, 6, 7 spaces left. Who's doing 7s for us? Who's doing 7s for us? Ariana? We don't have a lot of 7 spaces left, right? What do we have left? Let's do the column first. What comes after 42? There you go. And we do the same thing across, right after 49 plus 56. Now we only have 4 spaces left. Who's doing 8s for us? Who's doing 8s for us? Allie? I thought you had your hand up.
Well, yeah.
We only have 2 spaces left for the 8s.
Okay.
So after 56, what happens?
64 and 72.
Make it a 72 right here. Same that everybody else has? Everybody's on the same page, right? We're on the same page? Anything different? You guys feeling pretty good? We're missing one number. One number. And it is 9 times 9. What's 9 times 9?
81.
That's right. And that's it. Done. Look how quickly we did that. Let's see what we have here. And we got, let's see, we've got the grouping models. Anybody questions on the grouping models? Does that have to do with grouping?
Yes.
Okay.
First of all, the grouping is very easy.
Does everybody else think the grouping is easy? Who thinks the grouping is easy? If the grouping is easy, then we should be able to go through this in about a minute.
And second question is,
Go ahead.
you know I'm saying
Okay, so,
my grandpa built the middle school.
guys. What can I do here? Can I just start making dots until they add up?
Yeah.
Now, what if I started with 1 in each? 1, 2, 3, 4, 5. Obviously, that's not enough. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Hit it. Done. That's it. That's all you have to do on those. That's it. Now, what is 25 divided by 5, guys? You should know by the dots. 5. Okay. Same thing here. 1, 2, 3. Yes, I know it's a bad circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. How many dots do I have there? How many dots, Jed?
7.
That's right. So 21 divided by 3 equals 7. Easy. Now what about the next one? How many groups should I draw on this next one?
4.
How many dots should I have in each of them?
12.
As soon as he gets back. How many dots should I have in each of these? 12 divided by 4.
3.
3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's it. That's it. What about the next one? How many groups should I have, guys? How many groups in this one? Bless you. How many dots should I have in each one of those?
4. 4, 5, 5.
Yeah, because 20 divided by 4 is what?
5.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We hit 20. Chocolate chip cookies. Yes?
There's another one of this problem.
I know there is. So, this one, if you didn't do it, cross it out.
I already did it.
That's fine. Leave it. If you did it, leave it. If you didn't do it, cross it out. 2. How many dots do I need in each one of those? How many dots? 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Which means our answer is 9. Okay, let's see, we need 8 groups here, correct? 1, 2, 3, 4, 5, 6, 7, 8. How many dots do I need in each one?
8.
How many dots do I need in each one?
4.
Because 32 divided by 8 is what?
4.
That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. I counted wrong. 32. I counted too fast. Andrew. You could have done 32 groups, but that didn't work. You could do that as well. Now, reading the grouping models, guys. These are pretty easy. What do we think? What is this one? What is my multiplication factor? What is the equation? What is it? Heston. What's this one right here? Not 6 divided by 2. That could be 6 times 2. which equals how much?
12.
Now, if we were to do it as a division problem, because again, we are in the division section, and I actually led you guys astray by doing this as a multiplication problem. Now they're related, but let's go back. This is actually going to be 5 divided by 1, which of course is also going to equal 5. So now if this was going to be a division problem, what would it be? What would it be, Jack?
3.
No, if it's a division problem, how many dots do we have? 12, right? So it's going to be 12 divided by 6 equals 2. So 2 in each one. So be careful. Don't make the mistake I made. Be careful and make sure that you read it and didn't turn it into multiplication when it's actually division. But recognize as well that there's a relationship there. They are the same thing. We will go ahead. What about this one here, though? How many dots do we have? We have 1, 2, 3, 4, 5 circles with how many dots in them? How many dots in each circle? Aiden? Okay, go clean it off in the bathroom. As long as nobody's out. Yeah, go ahead. Esther, how many dots do I have in here? 6. There's 6, right? So we know that it's 4 times 6 because we have, 5 times 6. Because we have 5 circles with 6 in each. 5 times 6 equals what, guys? What's 5 times 6?
30.
Is that it? You see the other one is going to answer that one? So what's the division problem then? Jack?
5 times 6?
No, it's a division problem.
No.
Start with the product. Start with the number of dots in the middle.
30 divided by 6.
30 divided by 6 or 30 divided by 5. Because there are 5 circles. Allie. Okay, are you drinking water? Okay, you gotta get yourself some more water. And eat your snack. Okay? What about here, guys? We've got 3 in each and 2 there. It's 2 times 3, clearly. Which equals what? What's 2 times 3?
6.
That's right. So what's the division problem here then? What's the division problem, Andrew? That's right. Okay, this one here. Whoa, I went way too far. What is this?
3.
They're both 3, right? But there's only 1 in each one. So what is this problem? What is this problem? Yes.
1 divided by 3.
3 divided by 1. Remember, you can't divide 1 by 3, but you can divide 3 by 1. You can't divide the smaller number by the bigger number, right? You want the bigger number to be the one you do first. Does anybody have any other questions? Who has these? What's the division problem for this one? Who did the actual division problems for these and didn't just solve them? Ariana? What's the division problem for this one? It's 8 times 5. 8 times 5. And 8 times 5 equals what, guys? What's that now?
40.
So our division problem is going to be what? Let me give you a hint. It's 40 divided by what?
8. 5.
You could do it either way, right? You could do it either way. Because there are 8 circles, but there's 5 dots in each one of them. But they work the other way as well, doesn't it? Okay, what about this one right here, Andrew? Andrew, go ahead and go to the back. There we go. That works. Could have done 12 divided by 2 equals 6 as well, right? It's giving you the same information, is it not? It's also 2 times 6. That's the same thing. This is why grouping helps. What about this one right here? What's the division problem for this one right here? Tell me. You can do a multiplication problem. And it's what? It's not 4 times 16. It's 4 times 4 equals 16, right? Now if you have the 16, how would you turn this into a division problem? You got it. What's the answer? That's right. That's right.
In the 8 times 5 is 40. I did 5 times.
You can do that as well. Yep, mutative property. Does anybody have questions on the grouping? Questions on the grouping, Aiden? Okay. I don't think there's anything else we could do for it. You can see if you can get Ignite's back, yes. That's it. Good, you think it's easy. So you did division problems for all of them?
No.
Yep, then you didn't do it all the way. You gotta do division problems for them. Yes, it does. It says right here. Division facts. That's why I did both on each of them. And also to show you the relationship between multiplication and division, right? Yes. Jack.
I know we've already done this, but can you do it more?
You want to keep doing them? I know. I think some of you are getting a little mathed out. Okay, so we still have the repeated subtraction. I'm hoping you guys understand how to do those. I will skip past those for now to give you guys a little bit of time because we did start doing it. But guys, keep in mind, I want to point this out on these. I do it like this just to show you, but you didn't have to actually work it all the way out if you already know the answer. You could have just said 21 minus 7 minus 7 minus 7. And I would have also accepted that. Okay? So that's going to be the same thing here. Remember this. What's 20 divided by 5, guys? Who knows 20 divided by 5? Ian? 20 divided by 5. What times 5 equals 20?
4.
That's right. So, we know we need 4, right? So we would just say 20 minus 5, minus 5, minus 5, minus 5. You guys see what I'm doing here? Does that make sense for the repeated subtraction? It's the same thing on the next page, okay? Same thing on this page here. On this one, it's actually even easier because all you're doing is counting the number. 14 minus 7 minus 7 is the same thing as 14 divided by 2. Because there are 2 7s, right? Right here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 2s. So it's 18 divided by what? If there are 9 2s there, go ahead. It's 18 divided by what? Wilkins?
9?
You got it. That's it. That's it on these guys. So these make sense. Can I call on anyone in this room and you'll tell me this answer? Go ahead. Is that a yes? That's it. 15 minus 5 minus 5 minus 5. How can I do that as a division problem?
15 divided by 5.
Could do 15 divided by 5. Or I could do 15. 15. No. Has to. The 15 divided by is right. Yes.
15 divided by 3.
Now, Heston's not totally wrong because 15, of course, 15, excuse me, that's a 5, Allie. 15 divided by 5 equals 3. So you could look at it both ways, right? But look at how we did things on this page. And we're trying to follow the same pattern, right? So if we did 24 minus 3, what is 24 minus 3? What's 24 minus 3? Excuse me. Who's going to call me out on this? Come on, guys, call me out. 24 divided by 3. What's 24 divided by 3? Jack?
8.
So we could say 24 minus 8 minus 8 minus 8, and that would work. Or you could have done 24 minus 3 minus 3 minus 3 minus 3 minus 3 minus 3 minus 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Well, that's like a lot of them. But so really, honestly, though, if you're going to use it, in a way to help you if you don't know one of the answers. These you guys know the answers. You're doing really well. But if you didn't know the answer, if you didn't know it was 8, you would actually want to do it the other way and say 24 minus 4 equals, and you'd want to work it out just like I did up there. Okay? But if you know the answers already, then it makes it a little bit different. Which is why when you draw them out down here, when you write them out down here, you can do them multiple ways. You could have done 15 divided by 4 is 5, or 15 divided by 5 is 3. Because they're actually giving you the answers already. 1, 2, 3, 4. 24 divided by 4 equals 6. Same thing as 24 divided by 6 equals 4. You guys see that? Does that make sense? Ain't it? Okay, yeah, go ahead and do that. 32 minus 8 minus 8 minus 8 minus 8. What is this one, Joel? As a division problem, what would it be? We know it's 32 divided by something. What could it be? And what's the answer? It is. It's 8. What's another way we could have done it? Nick, what else could we have done here? We did 32 divided by 4 equals 8. What else could we have done? Go ahead. And you go ahead as well. What else could we have done? Well, we wouldn't want to do, we do 8 times 4 equals 32, that's for sure. But what if we did this? 32 divided by 8 equals 4. We could have done that too, right? Because look, we have 4 8s. So you could have done 32 divided by 4, so 4 8s and know the answer. Or you could have said, well, I know I've got an 8 here, and they drew it out 4 times. 32 divided by 8 equals 4. Okay, last one here. 1, 2, 3, 4, 5, 6. 6 9s. If I have 6 9s, you know it's going to be 54 divided by. What is it? What is it? Schmidt, answer, and then you can go.
54 divided by 6 equals 9.
Yep, what's the other way we could have written that? Go ahead and go.
54 divided by 9 equals 6. That's
correct. Do you guys see that? Does that make sense? Does it make sense, guys? Thumbs up if it makes sense. Questions? Jack, question.
I cannot find that page when you were going over it.
You said what?
I can't find that page when you were going over it.
What do you mean? That's it right there. Yeah, right there. Where? Do you have a question? Nope. I need you to figure it out now based on what you see here. I'm not doing the work for you. I'm showing you how to do it. So those of you who are not done with this page, you're using this as your example, okay? Not as copying down what I've written. Using what I did as an